Next, we're going to go over our final lesson on circles, which has to do with central and inscribed angles. So your two angle types are over here on the left, central and inscribed angles. So the first one let's talk about is the central angle. In a central angle, the vertex is at the center of the circle. So this red dot that I put right there is the center of the circle. So you'll notice that that central angle is 40 degrees. When the central angle is 40 degrees, this angle out here along the arc is also 40 degrees. They're congruent to each other. When you talk about an inscribed angle, the angle is on the circle. So you'll see that red dot right there where it says 20 degrees. So that inscribed angle right there is 20 degrees. I would double it to get the angle out here on the arc, out here that we said was 40 degrees. The other way you could think of it is if they gave you that arc angle was 40 degrees, you could also take half of it to get the inscribed angle that's 20. So that equation can go either way. That's why there's two equations listed over there to the right. So that's the difference between central angles and inscribed angles. Central angles are congruent between the central angle and the arc angle. An inscribed angle is always half as big as the arc angle. So now let's jump down here to the bottom and do a couple of example problems. Look at number 1a. So you'll notice that you have a central angle that is 2x minus 15 and an arc angle that is 45 degrees. Based on our definitions at the top, those two angles are congruent, and anytime we have two things that are congruent, we can set them equal to each other. So I would say 2x minus 15 equals 45. And it just asked me simply to solve for the variable, so I'm going to solve for x here. I'm going to add 15 to both sides. So I get 2x equals 45 plus 15 is 60. And then to get x by itself, I would divide both sides by 2. So my final answer for A is that x equals 30. For example B, I'm going to be dealing with an inscribed angle. So my inscribed angle is 5x, and my arc angle out there from A to C is 60 degrees. Now remember, the inscribed angle is half as big as the arc angle, or the arc angle is twice as big as the inscribed angle. So if I want to solve this equation, and I want to multiply that 5x by 2, so I need to double that to set it equal to the arc angle out there that's 60. Alright, now to solve this, I'd multiply 2 times 5x, and I would get 10x equals 60. Then I would divide both sides by 10. So my final answer is x equals 6. The other way I could have done this problem is I could have set 5x equal to 1/2 of 60 if I wanted to use the other equation. If I did that, I'll go ahead and work that out. If I did that, I'd have 5x equals 1/2 of 60 is 30, and then I would divide both sides by 5. So I get x equals 6 no matter how I do it. For example C, you'll notice that DC is a diameter. I'll highlight that in red right here for you. So that is a diameter. You'll notice that angle A opens up to that angle. So right here, we're talking about angle A, opens up to that. So what that tells us is that this arc angle out here would be 180 degrees. Now remember that the inscribed angle, so angle A in this case, is always half as big as that arc angle. So we know that angle A out here would be 90 degrees. Now you'll notice that I have that red triangle drawn right there. This goes back to previous lessons where we know that the interior angles of a triangle add up to 180 degrees. So to solve this problem, I would simply add the three angles together. So 3x plus 2 plus 90 plus x, and set those all equal to 180. Alright, when I simplify my equation right here, I would get 4x plus 92 equals 180. That's just combining like terms. I would subtract 92 from both sides. So I would get 4x equals 180 minus 92 is 88. And then I would divide both sides by 4. So my final answer here would be 88 divided by 4, which is 22. In our final example here, we have two variables to solve for, x and y. Let's look at x first. X is an inscribed angle that opens up to this arc angle of 30 degrees. So remember that an inscribed angle is always half as big as the arc angle. So I could say that x equals 1/2 of that angle 30 degrees. Well, what's 1/2 of 30? 15, so x equals 15. Okay, now let's look at y. Y is also an inscribed angle. I'll do that one in blue here. And it also opens up to that arc angle of 30 degrees. Let's say if I wanted to do this the other way around, I could say that 2y, if I double y, would equal 30. If I divide by 2 on both sides, I would get that y equals 15. So there's a couple examples on the differences between central angles and inscribed angles. Okay, moving on to the next page. Number 2 says if circle E, in circle E, the measure of angle AEN is 18 degrees. So let's mark that right here. AEN is 18 degrees. It tells us that JN is a diameter and that angle JES is 90 degrees. So right here, I'm just going to put a right angle box right there for 90 degrees. All right, so what we know here is we're dealing with all central angles. So if AEN is 18 degrees, this arc angle out here is also 18 degrees. If JES is 90 degrees, this arc angle out here from J to S is 90 degrees. So I'm just going to go ahead and mark those on the picture before we start answering these questions. All right, so the first question says, what's the measure of arc AN? All right, so arc AN is out here, which we already just said was 18 degrees. So there's our answer for that one. The second question asks for the measure of arc JA. So JA is from here to here. Now, we know that AEN was 18 degrees and that arc angle AN was 18 degrees. So to figure out what JA is, I would simply subtract 180 and subtract that 18 off of it. Okay, since they told us that JN was a diameter, we know that's 180 degrees total. So my answer there would be 162. I'm going to write it underneath. All right, the next one is asking for the measure of JS. Let me change colors here. Let's do this one in yellow. So JS is this one out here. So we said that a second ago that was 90 degrees, so we just need to write that in. All right, and then the last one asks for the arc JAS. Okay, so this is a major arc, so we know that it's going to be greater than 180 degrees. So from J to A, all the way around here to S. Well, we said just a second ago that this was 162 degrees out here from J to A. We know that this is 18 degrees from A to N. And then to go from N to S, we need to figure that out. Well, we knew that we had a 90-degree angle over here from J to S. So that means that this one here is also 90 degrees, which means this is 90 degrees out here. So that purple arc angle that I drew in there, we just need to add those numbers together. So it'd be 162 plus 18 plus 90. We add all those together, we get 270 degrees. Moving on to example 3 now. In circle C, it wants us to find two angles here, the measure of angle ACB and the measure of angle ADB. So the first one is ACB, which is this angle right here. To find that out, we need to know what this arc angle is out here from A to B. It tells me in the problem, the given things in the problem are that from A to D is 145, and then from B to D is also 145. Well, we know 1 time all the way around the circle is 360 degrees. So if I subtract those two other arc angles, 145 and another 145, I should get the measure of arc angle AB. So when I subtract those two things, I get 70 degrees. So from A to B would be 70 degrees. Well, we know that central angles are congruent, so both of those green arcs are congruent angles. So this is also 70 degrees right here. So the measure of ACB is 70 degrees. The second question asks for the measure of angle ADB. Now remember, ADB is an inscribed angle. So in an inscribed angle, this angle right here, remember that's always half as big as the arc angle. So all I need to do is take that 70 degrees and take half of it. So I'd take 1/2 of 70, and that should give me my measure for angle ADB, which is 35 degrees. That's it for our lesson on central and inscribed angles.